Okay, good afternoon. Um, in the best tradition of live demonstrations in computer science, the really cool Ultra Plot 9 graphics I was going to draw for you in real time have been failing miserably. So I've got a lot of pretty pictures to show you. I will do some programming in real time, which I will later post to GitHub. But we're ready anyway. I want to start out. There's been a number of questions on Slack, which is great. Keep them coming. Email questions as well, also fine. And so I want to go over some things and make sure things are working and answer some questions. I want to first talk about Lab 9. I understand some people were having some trouble copying the files and also having some trouble importing. 3 or 4 different people told me they were having trouble importing on Lab 9. This is due tomorrow night. So we can go over that. I want to show you on GL how I did it. First of all, the copy statements, I may have left the users out of the path, but these are the correct statements: AFS, UMBC, EDU, users, AR, Arsenal, pub, hail.py, and pub.py. I'm sorry, go ahead, question? Okay. So what I want to do, let me share my terminal. Okay, and let me make this a little bit bigger. I'm going to SSH into GL. Now I made a special directory to do this in called PyTest. And I copied the files fib.py and hail.py into this directory. So this should be the same as when you copy them. You'll see I've got some other stuff here because I've been doing a variety of tests to make sure this would work right. Now, some people said they were having problems importing even when they were in the same directory. In Python, there's something called sys.path, which will tell you the path that the Python interpreter will search in, all the directories it will look in to find a file you reference. So I believe that's the one I called test.py. Yep. Test.py just tests things out by calling import sys, so I can print the path statement, sys.path, and then it tests by importing hail and fib. When I run Python 3 test.py, you can see it works fine. It prints out all the directories it's going to look in. Now, it so happens that this very first directory it lists is the current directory. It's the one I'm working in right now. That should also be the case with you. If you if you're having trouble importing and you're pretty sure they're in the files are in the right directory, look at sys.path and see that that current directory is in there. You can actually insert it if it's not, but that should be the first thing you should do. So that is one thing you can do to check if you're having trouble importing. First of all, make sure you're copying correctly. Hail.py should look like this, and fib.py should look like this with the functions, and again, the trivial little main program. This is hail.py, that's the function you need with flight, and the trivial little main program, which gets ignored. And fib.py has the Fibonacci function you need recursively, and the trivial little main program that gets ignored. Again, if you're having trouble importing it, run a program just like this, test.py. It's not even worth copying mine. You can copy mine if you want it, but it's not even worth copying It's just these two lines, import sys, print sys.path. If you don't see the file you're in as the first directory in that list, sys.path, we've got a problem. We need to fix it. You can insert it. It's not a huge deal. So that was one thing I wanted to go over with respect to Lab 9, because I know a number of you have told me you've been having problems with that. So check that.
Question.
Certainly, go right ahead.
So every time you import within the terminal, not in Emacs?
No, you do it in Emacs. I actually, let me go back to the terminal. I created that file. So let's, where am I? Make sure I'm on the command line. Let's Emacs test.py. So I went into Emacs and I just wrote it right there. So this is what you would do. Just go into Emacs and write this program. Like I said, this is all I did. I just wrote it right there in Emacs, and then I saved it. And since I didn't make any changes, it automatically changed. It automatically do that again. Let's just add a blank line in there. So that's a change. So it makes me say, do I really want to save this file? Yes, I want to save the file. Always, disk file exceeded. Okay.
Question.
Yes, go ahead.
I think you might have touched on this, but could you please remind me again what the import sys does again?
Okay, it imports a bunch of features and parameters that are part of the operating system, so you can look at the path. So in this case, what happens is I don't need this for Lab 9. I only need this for debugging. I want to look at this variable right here, sys.path, to make sure it's looking in the right place. And so that's what this does, is this. If you have that problem, if you have that problem that you cannot get to, the can't seem to import the files because Python can't seem to find them, this is one of your first debugging steps. Your first debugging step should be to look at the sys.path variable and make sure your directory is listed in the directory.
Follow-up question.
Certainly.
So basically, I'm using PyCharm, and I have a folder called PyCharm projects that if the file that I'm importing is in that folder, it will find it immediately. But I've organized most of my stuff in folders within PyCharm
Right.
projects, and that doesn't work. It can't be in a folder in PyCharm project. It can only be in that. Is there any way I could point to the folder I'm talking about within PyCharm projects?
Absolutely, in the same way. Let me jump ahead to that right now. Here's how you do it. Let me create a new file so I don't mess up today's. And it's going to be called path.py. Just, it's arbitrary. It's a new file name. Okay, and so I'm going to do the same thing. I want to look at the system path on Python. So I'm going to import sys, and then I'm going to print sys.path. Okay, now I'm going to run this. What did I call it? Path. Okay, I'm going to run path, and you can see that it prints out the path that I have. It's a similar idea. It's the directories that PyCharm is using to search for these files. Now, if the directory you want is not in there, you can directly edit sys.path. So sys.path is a list. It's a list of strings. You know how to edit lists of strings. And typically you will want to insert it as the first thing. So what you will do is you will say sys.path.insert. Again, sys.path is a list. So we're going to insert an element into the list. I want it to be the first element in the list, so I'm going to insert it as 0. And then the directory name is just a string. So in this case, I would add on my Mac, users, Alfred Arsenault, downloads. Okay. So when I do that, and now I print sys.path again, and now I'll run this. Okay. And hopefully you can see that it's not clear. This is the first set of output from my sys.path. It looks in PyCharm projects, code from January 29th, thing like that. This is my second output, and you can see that it has put this new directory, downloads, immediately in the path as the first element. And so now when I do an import in PyCharm, PyCharm will look in that directory, the one I've got highlighted first. So Python will look there first for those files that I'm importing. So if you're having this problem in Python, in PyCharm, where you can't import the files because it can't find it, you can manually edit the path variable, sys.path, to insert whatever directory you want. You could go ahead.
Sorry, if we edit the syspath, will that affect it for all of Python or just for the program it's in there?
Only for this program. If you want to affect it for all of Python, then what you do is you go up. Now this is a Mac, not Windows. So with a Mac, you go up to preferences. Okay, and you edit preferences, and that's how you would change the path variable for everything. Is you would fool around with it in preferences for a Mac. With Windows, I believe it's settings. You would go up into PyCharm and you would find settings and you would change it there. So yeah, you could change it for everything. You do that up at the top here in settings. If you do it like I said right here with the insert, it only works for this program.
Okay, perfect. Thanks so much.
Not a problem. So, like I said, I'm getting a bunch of questions like that. So let's address them. And again, keep the questions coming. It's a lot better that you ask them and we answer them. But I'm sorry.
Can I ask a tangent question about the project?
Certainly.
In your test output or the test cases, there is, when it goes under the first test, there's the user keystroke sequence. In that, the last name Wheaton has like uppercase letters and lowercase letters. It's like a really wonky kind of string. Is there a legal way for us to, I guess, compare or work around that? Like, what is the legal way for us to do that without pulling solutions off the internet?
Absolutely. The short answer is with strings, you can cast them all to upper or all to lower. Now, in this case, I don't care what you do. Either one is okay. So what you would do is you would take that input as a string, right? And then you would set it to all upper or all lower. I think in my solution, I did all upper, but that's just me. Lower is fine. So you would say something along the lines of, let's say, I'm going to insert an extra couple of lines here. If I read in the string S, the last name, let's call it S equals the input, and that's how I got the name. What I would do is I would say last name equals S dot lower. That casts it to all lowercase. If you went to upper, I could say S dot upper. That would also work. That would cast it to uppercase. So what you would do is you would cast both the last name in the data file and the last name that was entered to either upper or lower. They have to obviously both be upper or both be lower, or they're not going to match. But yeah, the short answer is that's the easiest legal way to handle that is when you read in the last name, cast it either to lower or upper. I don't care. It doesn't matter. Both legit, both work. And then when you're comparing, compare to what's in your data file dot lower or dot upper, the same as you did for the other name. Okay?
Okay, thank you.
Not a problem. There is one more thing I want to talk about. Oh boy, that's a typo. Interesting. This is not homework 9 due next Monday. That's homework 6. There is no such thing as homework 9. Sorry. I do want to talk one other thing about about homework 6, which is a good lead in. Again, a bunch of people have been asking, so let's cover the question. There's probably a bunch of you have it and haven't asked yet. In problem part number 3, let me find part number 3. You have to reverse the characters into a string. There's an arbitrary string, may have blank spaces, may have any valid string character. That's fine. And then we're going to print it out backwards. You have to write a recursive function that takes one parameter, a non-empty string, and returns that string backwards. Then write a main program that exercises that function by prompting the user to enter a string. Now, the one catch I warned you of is a string is immutable. You cannot directly work on the string. Okay. So let me jump. I don't think I have a slide on it, but I'm going, so you've got the slide on I just posted them right before class to GitHub. You do have the slides. I want to go to PyCharm to illustrate this directly. Okay. So this is going to be a new set of code. Suppose that the user inputs the string, let's call it S, and let's say the user enters UMBC retrievers. And that's the string that I want to reverse. Now, the simple way to do it, you might think, is to create a temporary variable and say temp equals S sub 0, the first letter in the string. Now let S sub 0 equal the last letter in the string, S sub minus 1. Okay, and then S sub minus 1 equals temp. These 3 statements will normally be enough to reverse something, right? I copy the value of I take the first letter and I copy it off into some temporary location in memory so I don't lose it. Then I take what was last and put first, and I take what was this temporary value and put it last. Except the problem is, as we've seen, that this doesn't work. And the reason is that string is an immutable type, and you cannot, when it says you cannot does not support item assignment, that means specifically this statement and also this statement. But this statement is illegal because you cannot directly assign something to a member of the string. So what you're going to have to do is you're going to have to, let me comment this out. This is the code. This code is on the slide, so I don't feel guilty, but I had to give you this before. That's on the slide. What you're going to have to do is change the string into a list because we need a mutable type. The mutable types we have covered are lists and dictionaries, and a dictionary is overkill. You don't really need a dictionary for this. So what you're going to do is you're going to cast the string to a list. Now, normally we would think of splitting something because that's what the split method does, right? A split takes a list and it returns a string. Well, okay, so updated S equals S dot split. Now I have a problem. What am I going to split it on? It's an arbitrary string. It may have blank spaces. It may not have blank spaces. If it's got blank spaces, I may not want to throw them away. If it's got commas, I may not want to throw them away. And remember, when you split, you lose that, whatever you're splitting on. So it just seems that splitting this function, right, is a really bad idea. Splitting this string, let's try that in English. Splitting this string is a really bad idea. It's just not going to work. So I can't use split. So now I have to come up with another way of splitting this string into a list, into a mutable type. So let's comment that out because we know it's not going to work. Okay, well, with a list, you've always got to start with a blank one or you've got to fill it in. We'll just start with a blank one. So L is going to be the list version of the string. What am I going to do? I'm going to start with a blank list. Okay, that's fine. I'm going to go through this string letter by letter, and I'm going to append it to my list. So it seems like if I have an empty list, I now want a list with a capital U, then a list with a capital M, then a list with a capital B. So there's a couple of different ways to do it, and I think I put a couple of them on the slide. Either of them will work. You have to twiddle around with them a little bit. But if I just say L dot append parentheses S sub 0, let's see what that does. Let's make sure I've got S down here. I don't need to reload that. If I just append the first variable, now I've got a list with the U. Now let's append S sub 1. Okay. And now this looks like I'm getting somewhere. This looks like I'm building a list whose elements are the letters of the string. So I follow this, and it's left to you to come up with the exact syntax that's going to get you the whole string, but you can follow this pattern. Now I can also use slicing. If you remember, if I have S sub I to I plus 1, that's going to give me a 1-character string included. So this syntax will give us exactly the ith character of the string. So if I say S sub 3 to 4, that gives me the capital C in UMBC. Okay, if I say S sub 8 to 9, that gives me the R in retriever. Okay, or one of the R's in retrievers. There's 3 of them. So I could do, going back to the slides, I could do this middle thing says the split doesn't work. I could do 1 character at a time, and I could either directly append it or I could slice it. Either of those 2 ways would work perfectly. And so that's what you're going to have to do for part 3, right? You can't directly operate on that string because the string's immutable. So you have to break it up. Split doesn't seem to work because split always throws something away. We don't want to throw anything away. And it's an arbitrary string anyway. We don't know what we could possibly throw away. So therefore, we're going to have to slice off 1 character at a time, start with an empty list, and build our list. Now, when you have this list for part 3, then, as I mentioned, then you can start swapping the characters. You can swap the elements of the list, do it recursively, and that's where you're going to get your solution. So it's fairly straightforward, but I want to make sure you understand there's going to be some limitations on what you do. So that's homework 6. And a number of questions again about downloading and installing Python modules. Generally use pip. Pip stands for the package installer for Python. You can use Conda, but I recommend pip. In a Windows command window or a Mac terminal or a Linux command line, you just simply type the phrase pip install name of package. So I was planning on talking about Plot9, and I will talk about Plot9 a little bit. I just won't give live demos of it, but to install Plot9, I go back to a terminal. Let's get out of GL. Now I'm back in my MacBook. My quota on GL is completely used up because I installed a whole bunch of packages testing it out this morning. So I've got to edit a bunch of stuff and throw some stuff away, which is fine. But on my Mac, I would simply type pip install plot9, the pip function, the pip code is smart enough, and I'll make that a little bit bigger, is smart enough to understand what that means. It has to go out to a repository. It knows where the repository is. It can find it, and it could download. Now, I've already installed plot9 on this machine, so what I should get is a whole bunch of messages saying you've already done this, but it would work like this. You get a whole bunch of code like this. You get a whole bunch of messages telling you what's been installed, what has not been installed, and then you can move on. So that is how you download and install Python modules. You will need this next week. You will not need it until next week. But of course, if you're gung-ho and you finish your homework and your project and your lab and you want to play around with it ahead of time, feel free. That is how you do it. Okay. Moving back to presentation mode. Now we've covered all the background. If anybody has any more questions, like I said, I think this lecture is probably going to end early. I'm more than happy to, at the end of time, answer any questions or hopefully give some more examples. Now I wanted to talk about graphics. Remember, this week is the unit of Python Beyond 201. It's some of the really cool and neat things you can do with Python. And one of the things Python's used for a lot is graphics. When I say graphics, that's a whole bunch of things. Animation, like Pixar movies, which you know are not done in Python. Plots and charts or drawing simple figures. You actually could do animation like Pixar in Python, but it really doesn't run very fast, so it would take you forever. But you could do it. Plots and charts, on the other hand, are great. Simple figures are great. And again, the advantage to Python is that there's a ton of tools for doing whatever you want. We're going to start by talking about turtle graphics, and all that requires, turtle is usually included with a Python distro, so you don't have to install something. You just import turtle, and we'll give some live demonstrations of that and show you how it's done. And then for more complicated plots, you can use something called plot9 or ggplot to visualize and analyze data. And I've got some snips I made of some earlier coding and downloads because, as I said, right now plot9 is deciding not to work well on my Mac, so the live demonstration would be completely a failure. And we're going to show some clips there that you can go out and look. Again, pip install plot9. Plot9 is normally not included with your Python distro, so you would have to install it using pip, unlike turtle, but you can do that. Now we'll do a little PyCharm coding with turtle. The idea is that you open a new blank window and you can draw simple figures and control them by commanding a turtle. The cursor is considered to be your turtle. You create one of these turtles, you tell it to move a certain number of pixels in a certain direction, and then you turn a certain number of degrees, positive or negative, and then move more pixels. Okay. You can draw lines, you can draw simple shapes. Now, if the shape you happen to draw is a closed shape, and turtle is smart enough to figure out if it's closed, you can fill it. And we'll demonstrate that. You can change the color and thickness of the line. You can pick your turtle up and move it to another part of the screen, and thus you don't have to always draw a line from point A to point B, because the turtle up and turtle down functions allow you to do that. So get some, since I haven't failed with my code in much, let's start with that. So I'm starting out with this will be posted. It's not on GitHub yet, but when I finish with this, it'll all be posted. I'm going to import turtle. And again, I don't have to install turtle because it comes with a Python package. And when I installed Python 3.7, it should be there. So turtle should be there in your case. Now, I need to create a turtle first. And so I'm going to call it Bob. Okay. I create a turtle by saying from the turtle module, I'm going to inject the capital T turtle method, and that creates a turtle. And I'm going to name my turtle Bob. Now I'm going to tell Bob to move forward 200 pixels, and then he's going to be done. Let's this. Let's run the April 22 program. And what it does is it creates a new window and it draws a line. And so this is 200 pixels on the screen of my Mac. By default, Turtle always starts in the center of the screen. And you see this is the center of my window. And forward is to the right. Okay, fairly simple. I can draw a line. Let's make it a little more interesting. We're going to change its color.
Is it only me that can't see the line?
No, it was a really trivially thin line. Sorry. I think let me run this again and I'll try to blow it up. Or it's possible I'm not sharing that window. Let me see if there's a new window I need to share. That's a good point. Okay, now I'm sharing the screen. Does that help?
Yeah, we can see it now.
Okay, yeah, so that's what happened. That window was not being shared. Sorry about that. I didn't even think about that one. Live demos and all that stuff. I'll keep sharing the screen for the next little bit. Okay, so now I'll close this window. I will make Bob a little thicker so he can be seen by saying bob.width. And again, width is going to be given in number of pixels. So I'm going to make him 30 pixels wide. And I'm going to give him a color. And the pen color, this is a, Turtle Graphics uses a red, green, blue spec. You can either name a color if it's a color that's defined, or you can tell it how strong to make red, how strong to make green, and how strong to make blue. Now, we're going to make it easier by saying, since green is a defined color, we're going to make Bob green. Okay, let's run him again. Now we see I've started in the center, and I've drawn a new line that's 30 pixels wide, and that is the color green. Okay, and the lines are boring. Let's draw a square. Now, if we draw a square, what we can do is we can move forward 200 pixels. Then we can turn right 90 degrees. And we can do that 4 times. By the way, this last line, this turtle dot done, is what makes that second window stay up there. If I remove that turtle dot done, you'd never see the window because it would only be on the screen long enough to draw the figure, and then it would go away. So that's what the turtle dot done does. It's just a strange idiosyncrasy that I have to do this. So what we're going to do is we're going to draw a square that starts in the center, goes forward 200 pixels, makes a 90-degree turn, goes forward again, which will now be down 200 pixels, and repeats that 4 times to draw a square. And thus, using these very simple commands, you can draw a square on the screen.
Question.
I'm sorry. Yes, go right ahead.
Just making sure since forward is to the right, bubble to the right is just making a turn.
Okay, yeah. When you start, by default, when we start, forward is to the right of your screen. That's this. This is a turn. So this says turn right or turn left. If I wanted to, if I told Bob to turn left here and run it, I still get my square, but it goes the other way because Bob is turning left, not turning right.
Got it. Thank you.
All right. Now, if I wanted to get fancy and draw a 5-pointed star, don't want to get too big, so I'm just going to have him draw 100, go 100 pixels. It turns out if I have Bob turn 144 degrees at a time and draw 5 sides, that does not look very good. It is a five-pointed star. Let me make his width 10 instead of 30. And let me make him go 200 instead of 100. And let's try that again and see if we get a little bit of a better star. That's a little bit better. You can see that that's a 5-pointed star. Okay, so you can draw all of these strange and interesting figures, but it's simple. If you want to draw figures on your report, or you want to make things look pretty or whatever, Turtle Graphics is pretty cool. The one other thing I'll show you before we move on to a different graphics package is fill. So I'm going to say bob.fill color. It's going to be red. Let's make it blue. And now I'm going to do bob.begin fill. And then after I've drawn the star, I'm going to say bob.end fill. And as long as what I've drawn is considered by Python to be a closed figure, it should fill it when it's done. Yep. Now, interestingly enough, it considered the points of the star to be closed figures. It did not consider that funky looking pentagon thing in the middle of the star to be part of the closed figure, which is why it didn't draw it. You can do other, you can do a circle. Circle is predefined, and you can draw all kinds of funky little spirograph looking things and the rest if you wanted to. So that is Turtle Graphics. It's a fairly simple thing. Let me go back to share. The share button is right next to the mute button, and I hit the mute button every time I go for share. Let's go back to sharing Chrome. So that is Turtle Graphics. It's a fairly simple, straightforward thing. It's nice. I mean, you can play with it. You can toy. You might be able to put something you need in a paper if if you're writing a paper and you need interesting little simple geometric figures. You can do it. So it's nice to know about, but it's really not much more than a toy. At least I've never seen anybody do much more than that. There is a generic plotting library. It's been available for a long time. That can be called by Python. It's called GNU plot. GNU is an organization founded by a group called the Free Software Foundation, or FSF. It was the original group that really believed in an open source free software that was available. And so you see a lot of things that are called GNU that either came from that group, or in this case, this was not from them. It was inspired by them. GNU plot is useful for defining and drawing a whole bunch of interesting mathematical functions and formulae, and you can take a look at it. In previous semesters of this class, the non-major section of 201, Dr. Mitchell had people download and use GNU plot. It can be called by Python, but it is not Python. It's actually written in C++. But what I have done is I copied into the lecture notes repo on GitHub. There is a file just to explain what it's doing there. Lecture notes, here we go. I think I put it in lecture notes. Maybe I didn't. Maybe I put it in homeworks. Let's look at homeworks. There we go. This file right here, installing a GNU plot, is for your information. You do not have to use it. We won't be using a GNU plot in this class. But if you're interested, it was Dr. Mitchell's from last fall before she retired. The detailed instructions for installing a new plot on your Windows or on your Mac. And she has all the pictures and screenshots and everything that it should look like. Presuming you're using a Windows 10 box. If you're using a non-Windows 10 box, it will look a little bit different. That's on there. If you've got a Mac, her instructions, I was playing with them a little bit earlier today. They do work. So it's nice. It's free software. You can play with it. There's a Python interface to it that you could use. And basically what you do is you put code in Python that calls your new plot and draws fancy graphics for you. If you like it, as I said, you can see from Project 3 that Dr. Mitchell used it last semester. I'm not knocking it. I'm not denigrating it. It's just not my favorite. There's a later, newer thing that I like a lot better that we're going to talk about that we're going to use in Project 3, and that's called Plot9 or ggplot. So we'll go to there. Now, ggplot, GG stands for Grammar of Graphics, and it's a new way of, or a newer at the time it was invented way of drawing graphics for data analysis purposes. Now, there's a language R you may have heard myself and a couple of other people talk about. R, computer scientists have no imagination. The language C was the successor to a language called B. The language R was the follow-on to a language called S. I guess they didn't want to go from S to T. They went from S to R. R is used very heavily in big data, data analytics. It's used for people who are doing all kinds of, load a billion tweets and analyze them for tips to what's going on in the world that hasn't made the news yet. Okay, R does that. Well, Python is really taking over that space. Python is a lot easier than R, but it needed a nice graphics package because the guy who developed R, or who was primarily responsible for R, was a guy named Hadley Wickham, and Hadley wrote the whole ggplot package to do graphics, and trust me, it's really cool. So Python had to come up with its own version of ggplot. There's 2 or 3 equivalents. Plot9 is the best implementation, so that's the one we're going to use. Okay. Plot9 works like the original ggplot on what's called a grammar of graphics. That's what the GG stands for. And the grammar consists of, first of all, a basic object. So the object itself is called the ggplot. The ggplot refers to an actual object. To that object, you then layer on top what's called an aesthetic. And you'll see in the code samples, aesthetic is abbreviated AES. Now, if you're familiar with vocabulary, aesthetic means how something looks. The aesthetic is what color scheme, it's the architecture, it's the design, it's how pretty something is. So the aesthetic tells Python how to draw this thing and how to make it look nice for what you consider nice. That's the aesthetic. For example, in the aesthetic, you tell it what labels to use for the X and Y axes. Since this is plotting, again, this is not animation, this is not drawing cartoon cells, you're not going to do Woody and Buzz. Most things are done with an X and Y axis, and so you can tell in the aesthetics section, you can tell it what labels to use for the X and Y axes. You can tell it what color scheme to use for points. So if, for example, you're plotting actual points rather than a bar chart or something, you can, color different points, different colors to make it clearer to the reader. Oh, these are the 4 speeds, and these are the automatics, and these are the 3 on a tree cars. After you've added the aesthetic, you then add a geometry or a geom. Now the geometry tells Python from a plotting standpoint what this is supposed to look like. This is a plot of points on an axis. We're going to look at individual things. This is going to be a bar chart. This is going to be, that's a typo. It should say stacked bars, not stacked parts. We'll show that. You actually, in some cases, will have a bar chart that's split into separate regions. You have bars stacked on each other to illustrate what's going on. You can draw a histogram. Then once you have developed your basic object and you've added your aesthetic and you've added your geometry to decide what you're drawing, then you can transform the data using statistical methods. You can draw a line showing the mean or the slope. You can draw a gray area representing a confidence interval, if you're familiar with that from experimental. You can do all of this in a single sentence. So what we've done now is I've captured a few things. Here is a case in this example. I've got my import statements, right? From the plot9 package, I've imported the ggplot module. The geometry point means this is going to be points on a line or points in the graph. I've imported the aesthetic so I can tell it what to look like. I've imported a statistics package called smoothing, stat smooth. So I'm going to apply to statistics to make this look better. And I've imported something called a facet graph. Now, plot9, when you download it and install it, comes with some free data for you to play with. It comes with a bunch of data on diamonds, how much they're worth based on cut, color, clarity, facets, weight, the whole thing. This one, the other one is this one. It's a whole lot of data about cars. Cars broken down to manual transmission versus automatic, rear-wheel drive versus four-wheel drive versus front-wheel drive. It's broken down to trucks versus SUVs versus whatever. It's just a ton of data you can take and look at to do some things with, and it lets you draw some examples. So I just imported the cars database. Okay. So now that I've got that, I wrote one statement. This is one Python statement. Draw a ggplot, draw a new object, taking it from the cars database. Empty cars is the cars database. Now, my aesthetic. What do I want this to look like? I want the x-axis to be labeled weight, and weight is going to be 2, 3, 4, or 5,000 pounds. MPG is the y-axis, what kind of miles per gallon I get. So the first two entries in the aesthetic entry in this list are the x-axis, weight, and the y-axis, miles per gallon. In terms of color, I want to use a color that is keyed to whether this is a 3-speed, 4-speed, or 5-speed. That's what gear means. Gear means 3-speed, 4-speed, or 5-speed. So I've told that by saying color equals factor gear, I've said I want different colors for 3 speeds, 4 speeds, and 5 speeds. Now I'm letting plot9, I'm letting Python pick its default colors for this. I could have told it I don't, I want, instead of red, green, and purple, I want blue, fuchsia, and periwinkle. It would work. I chose to just use the defaults. Okay. Now, after I told it I'm drawing a new chart based on these cars, I've told it geometry point. I'm plotting points. I'm not drawing a bar chart. I'm not drawing a histogram. I'm not drawing anything like that. I'm putting points on a scale, or on my chart. Now, the next plus says I want to apply the statistical smoothing. Basically, what I'm going to do is I'm going to plot all my individual points, but then I'm going to show a line that's, I'm going to draw a line that's the slope of all of these points. Okay. And I'm also, with the statistics smoothing, the method LM is the least squares linear model. I'm also going to draw a confidence interval. The gray thing around there is the gray thing around my line is the confidence interval that says, if I'm experimenting and I'm measuring, that's where the errors might be, but I'm pretty sure they're in that range. And then the last thing I'm going to do, facet wrap says actually divide this into 3 separate parts. If I didn't have that last statement, facet wrap, I would not get 3 separate graphs. I would get one graph with the 3 different plots on it. but this is an example of being able to split a single chart into pieces. Now, this is all documented. It's actually not that hard to get used to. It's just a little bit of practice. But again, it's essentially one line of Python from the left parentheses to the left parentheses before the ggplot to the right parentheses after gear is one line of Python. And given the data, it lets me draw this graphic, which is actually fairly cool. You can look at this and you can see, okay, the heavier a vehicle gets, no matter whether it's 3, 4, or 5 speeds, the heavier a vehicle gets, the worse its miles per gallon is. And that makes sense. Engineering and physics, heavier things take more energy to move. So this is just an example of what you can do. Here's another example. From the same data set, this is just a small part of the table. I've got a collection of Audis here. The ones I'm showing are all A4s with different engines, 1.8 liter, 2 and 2.8 liter, different years, 99s, 2008s. They're all 4 cylinders except for that one beast down at the bottom, which is 6. Automatic and manual transmissions, et cetera, et cetera. So what I'm going to do is I'm going to take this data, and it's not just those 5 rows, there's a bunch of other rows. And I'm going to draw a bar chart. So ggplot says draw me a new plot, a new plotting object that's going to show miles per gallon. It's going to be a bar chart because geom_bar says it's a bar chart. And my aesthetic, my x-axis is class. So the classes are defined as 2-seaters, compacts, midsize, minivans, pickups, subcompacts, and SUVs. And the count is just how many of them there were. So in this bar chart, it tells me that in this data set I had, there were only about 5 2-seaters. There were around 48 or so compacts. There were around 10 minivans, etc. So this is just a bar chart that shows how many of things. It's a good comparison that tells you, yeah, there's a whole lot of SUVs in this data set. Gray scale bar charts, which is the default, are boring. So now I want to use color to emphasize, and this is called a stacked bar chart. So this is what where it said stacked parts and that should have said stacked bar chart. This is what that refers to. It's a bar chart, but instead of just a single grayscale line that says this is how many of these I have, I've broken it down. Now the drive is broken down in my data set. This is, again, the data set that's downloadable with Plot9. If you want to play with it, I understand you're very busy. Not a problem. But we have rear wheel drive is R, and that's the purple thing. Front wheel drive is green, and 4-wheel drive is red. And so this says I have a little over 60, I think 62 SUVs. Of those 62 SUVs, right about 11 of them are rear wheel drive, and the rest are 4-wheel drives. There are no front wheel drive SUVs, which again kind of makes sense, I guess, based on my experience. I've owned like 2 or 3 different SUVs, so that's probably about right. Subcompacts, there's actually all of them. There's rear wheel, front wheel, and 4-wheel. Pickup trucks, there's only 4-wheel drives. Now that wasn't the full data set because, trust me, you can buy front wheel drive pickups that are not all 4-wheel, but people like them. Minivans are all front wheel drive, and so on. So this color scheme is driven by the clause up in the aesthetic line above. One line of code produces this plot. One line of code plus a whole lot of data, let's be honest, produces this plot. The color is driven by the fill equals. So the fill says take the Python defaults, and depending on what kind of drive it is, fill it in, and Python will add that little key over to the right side that says what this means. If you don't like bar charts that go straight up, you can flip it. The only difference here is the flip, and that is the second plus sign in the code above. where it says coordinate underscore flip, and that just causes the bar chart to be turned. And so instead of being from the bottom up, it's from the left to the right. Now, what this does is it's still, the x-axis, remember, was originally labeled class. Here, class is now on the y-axis, but that was because of the flip. In the code up above, the bar, it says x equals class, so that was on the x-axis. When I told it to flip the coordinates, that's what put it over on the left. You can do really fancy stuff. We're not going to go through this code, and no, I did not write this. But this is a map of Westeros from Game of Thrones. Actually, it's a map of part of Westeros. It's been truncated. On the right, the code on the left is all the code you need to produce that map, okay, with the entire color scheme. Everything on the left is, everything on the left drives that map and makes it print out that. The watercolor, again, this is a red, green, blue scale. So this says apply A3, and next week we're going to talk about hexadecimal, and you'll find out exactly what A3 means. That's how strong to make the red, CC to make the green, and FF to make the blue. Well, that tells you that you can guess that FF means make blue really strong, and sure enough, the water being pale blue is mostly blue. The second one says the wall color is white. If you remember Game of Thrones, they had a wall. The wall is white. And the road color for any roads, make it brown. Okay? So we do that. The next, there's a function that says when you label the things, when you write the text to label who owns what, who controls what part of Westeros, make the labels really big. Okay? And that's how, that's that function, fat labels. And then the rest of it from ggplot on down says how to draw the whole map. Geom map says it will preload. There are thousands, literally thousands of pre-drawn maps that are available for Plot 9. You can get them and use them. It says take Westeros, start out with no fill, draw the islands, then draw political subdivision, says who's claimed by, draw the wall, lakes, rivers, roads, cities. The text, we're going to use political text, which is all a bunch of names of who claims these things, text for the cities, etc. So that page of code on the left, along with a whole bunch of underlying data, you can draw that whole thing using Plot 9. And it's just a matter of putting it all together and getting the aesthetic that you want, getting the color scheme that you want, getting the labels that you want, getting the thickness that you want. And it's just a matter of playing it around. Just a simple example of working through, again, I cannot claim this. I think it's cool for the chemists and the chemical engineers of the class, since I know there's some of you. TLDR, jump to the bottom. We are going to draw the periodic table that will look like this using Plot 9. How does it work? Well, we start by using some things called tiles. And the basic element, one element in a tile, the periodic table is going to be a tile. So we start out with data that looks like this. We're coming in with a data, with a chart, or sorry, let's try this again. We're coming in with a table, a 2D list that looks a lot like this. It's actually being read in from a CSV file. And we're reading in the CSV file, and it's going to tell us the atomic number, the symbol, the name, the mass, electron configuration, et cetera, when it was discovered, where it belongs in the table, group, and period. And we're going to use this table to create the graphic of the periodic table. We're going to add columns called group, bonding type, metal, and atomic number for each row. So we're going to extend our 2D list. You know how to do that. That's in Project 2. The next thing points out that you've actually, with a periodic table, you can't do it in one table. You've got to do two, because the periodic table has these elements off the bottom that are done separately. And so we're going to have to draw the main part of the periodic table, and then we're going to have to draw that bottom part, the radioactive elements later. Okay. So we're going to make separate data frames for both, one for the top, one for the bottom. We lay out the bottom table with 2 rows. We lay out the top table with its rows. We define how big each tile is, though you will not have to do this. This is not part of the project. This is just showing you what can be done. And we actually lay it out upside down with the radioactive elements, the man-made elements down here at the bottom, and the natural elements up here that are going to be on top start up upside down. Then we flip it upside down with a scale Y reverse. This scale Y reverse is the command that flips your whole graphic upside down with just that one little part. See, it's starting to look like the frame of a periodic table. Now we just need to color everything according to what metal it is. So the next step, we apply some colors and we say this is what metal things are in, what group or period things are in based on what they belong to. That's our aesthetic, X and Y. Those are the labels. Aesthetic, fill by what value the metal is from the table. Use a tile. Use a tile for the bottom. And then scale Y reverse this, flip it upside down. Okay. Now we just have to put the text in each cell. We have a function that does it, that puts it there, and now we just draw with the text, inner text here, added to the plot. And so ultimately, we had to do a lot of work to get here, but ultimately this one Python statement, and again, from this left parentheses to that right parentheses, that's all a single Python statement. Whole thing to draw the periodic table. And then the rest of it is just scaling it to the right size. And playing around with color schemes to make it different and however you want it. The bottom line is it's all there. It's an interesting tool set because we can do all that with Python. In this class, you're not going to do that. I think this semester, if you take the follow-on class 291, pause a minute. If you take 291, which is the follow-on, this semester Dr. Johnson's teaching it. He's having you write a web app. You write an app that gets up there and stays out on the web for people to play with, and heck, who knows? It's popular enough, monetize the thing. It's the point of that last bit is just to demonstrate the power of Python, that with fairly simple statements, we can do very, very complicated things by building on everybody else's code. Okay, I believe that is my last slide. It took longer than I thought, but that's okay. There is still some time. Let me double check that that was the last slide. I'm pretty sure it was. Yep. Okay. So we are done. You have 12 extra minutes. I'll be happy to stay on and talk to anybody if you have project or homework or lab questions. And otherwise, enjoy your week and weekend, and I will talk to you next Monday. I will also be monitoring Slack and email and other things if you have questions there. So, anybody with questions, go ahead. Otherwise, talk to you next time.
Professor? Professor?
Yeah, go ahead.
I was wondering if there was a way to know what our grades are in the class at the moment, just because like so far we've only gotten homework 1 and homework 2 back from our TAs.
Right, they're still working on them. And again, I apologize, that's my fault. They're working on 3, 4, and 5. You do have the exam grades as well, though, right?
Yeah.
And let me check. Let me check on how they're doing on project. They stopped after doing homeworks 1 and 2 because they're supposed to be grading project 1. Let me see how they're doing on that.
All right, thank you.
Okay, yeah. Anybody else? Going once, going twice. Hey, thank you all. I'll talk to you on Monday.